Okay, just imagine this for a second. A critical gas pipeline, the very artery of a nation's energy supply, just fails. Catastrophically. After something like that happens, you can bet the pressure on the operators is absolutely immense. So the question becomes, how do you guarantee safety and reliability across thousands of kilometers of infrastructure? Let's be honest, the old ways of just watching and waiting for something to break, that's just not going to cut it anymore. And forget about just another dashboard or some fancy spreadsheet. We're going way beyond simple monitoring here. We're about to dive into a new kind of artificial intelligence, one that's designed not just to watch our most critical systems, but to actively run them. This is the story of the AI that decides. You see, this whole challenge has become a national imperative. For an energy network just monitoring the flow of gas and, recording failures after they happen, it's like trying to drive a car by only looking in the rearview mirror. You only ever see the problem long after you've passed it. It's totally reactive.
And that's really the heart of the issue with our current systems. They're all focused on the past. Yeah, they're great at telling us what happened yesterday, logging transactions, recording failures. But every single crucial action, like rerouting supply or scheduling maintenance, it requires a human to step in. There's no brain in the system that's constantly thinking ahead, optimizing things on the fly.
So how do you make that leap from this reactive world into a predictive one? Well, you give the network a brain. And that brings us to the core of this whole thing, a technology called autonomous optimization models, or AOMs for short. Let's break that down, because it sounds a little complex. AOMs aren't just analyzing data. They're designed to close the loop. What does that mean? It means they grab data, use it to make the best possible decision, and then, and this is the key part, they execute that decision automatically. It's this continuous cycle of thinking, learning, and acting, all happening in real time, all designed to get the best possible business outcome. It's a fair question, right? We hear about AI all the time. Chatbots, generative art, you name it. So you're probably wondering, what makes this AOM stuff so different from the technologies we already know? Well, here's where the real difference is. Think about generative AI or a data dashboard. They give you insights, right? They help boost your productivity. An AOM, on the other hand, is completely decision-driven. It's designed to directly improve profitability and your return on investment. While a dashboard needs you to hit refresh, an AOM is continuously self-learning. So to put it simply, one is a tool that helps humans make better decisions. The other is a system that makes optimal decisions itself. The big vision here isn't just to plug in some new software. It's way bigger. It's to build what you could basically call a digital nervous system for the entire network. An integrated system that can sense, think, and act, almost like a biological one. So what does it actually take to build something this complex? I mean, you can't just flip a switch and have it running. Nope, you have to build it layer by layer right from the ground up. It's basically a 6-layer cake. First up, you need a data lake. It just pulls in every scrap of information from everywhere. Industrial controls, IoT sensors, business software, you name it. Next, you visualize all that data by creating a digital twin, which is like a live virtual model of the whole network. Then comes this really cool conversational layer. It lets an engineer just ask questions in plain English, like, hey, why did the pressure drop over here? From there, the system gets proactive with alerts and root cause analysis, spotting problems before they even happen. At the very heart of it all are the core AOMs. These are the actual decision makers, optimizing gas flow and maintenance. And then, overseeing everything is the control tower, the master brain that autonomously balances the entire network for peak performance and safety. Okay, so you build this incredibly intricate digital nervous system. What does it actually do for you in the real world? What's the tangible payoff? Well, the results are pretty staggering.
First off, a 25% reduction in unscheduled downtime. Think about that. How? By predicting failures before they happen, the system can schedule maintenance proactively. This keeps the gas flowing and prevents those really costly and, frankly, dangerous interruptions.
Next up, a 15% drop in the energy needed to run the compressors that push all that gas through the pipes. By optimizing pressure and flow rates constantly in real time, the system only uses the energy it absolutely has to. That means lower costs and, of course, a smaller carbon footprint. And finally, how about this? A 10% increase in revenue. Now, this comes from pure optimization. The system is so smart, it decides where every single molecule of gas should go. in real time, based on what the market needs. Should it go to a domestic power plant or to a more profitable export market? It makes that call to maximize the financial return of the entire operation. So what we're really looking at here are two completely different futures. One path is the traditional one: static dashboards, analyzing problems after they happen, fragmented data. The other path? That's autonomous optimization, a self-learning system that actually prevents problems and runs the entire network from a national control tower. It's literally the difference between looking at a paper map and having a self-driving car. This quote just nails it. It really captures the essence of the shift. It's a leapfrog. You're not just describing what happened with your data anymore. You're actually turning that data into actions. And these are actions that are continuous, that you can actually understand and that have a clear, measurable financial impact. It's a total game changer. Look, this technology represents a monumental step forward in how we manage the systems that we all depend on every single day. It promises a future that's safer, that's more efficient, and way more resilient. But as we start to hand over the controls to these incredibly powerful digital brains, it leaves us with a pretty profound question to think about. When AI runs our infrastructure, who is ultimately in control?